So, hi Billy. Just a couple of things that we got to go over before we kind of attack this question here is because this is a parallelogram here, um, you're going to know that these guys meet each other. All these are 90-degree angles. Okay, so the bisectors here meet at 90-degree angles. So that's 90. You're told that this is 56 with a little smiley face there, but it didn't really work well. That's 56. You're also told that BDC, so BDC is going to be this angle here is, oops, smiley face. Let's go with something else. Let's just go with the purple dot here. This guy here is 33, so you're told that also. Okay, well, and these here are bisectors, so they're cutting through the middle. So that means if that's 33, then that has to be 33. Okay, so these two are the same size. You also know that because if this is 90, that's 56, and if you take 90 plus 50, add these two together and subtract them from 180, you get the third angle of the triangle, which is going to be the 33 degrees. So that's 33 and that's 33. And then if that's the case, you also know that's 90. If that's 90 and that's 33, then these three here have to add up to 180. So again, you go 180 subtract 33, subtract 56 equals 56. Sorry, subtract 90 equals 56. That's how you get this guy. Okay, 90, 33, and this. You also know that because it's a parallelogram, these angles are the same as these angles, and also that these two are the same because it's a bisector, so it cuts through the middle. So if these are both 33, then they add up to 66. These add up to 66, and once again, because they're cut in half, you take the 66 and divide by 2, and you get the 33. Okay, so just some properties there of parallelograms that probably make sense. They look like they make sense. So let me just go over them again real quick. The things that you know is that this is 90, that's 90, and that's 90, and that these guys here, these lines that go across in a parallelogram like this, they're going to make this angle the same size as this angle. Okay, and then if this guy here is 56, this one has to be 33 because what's left over from 180, because that's 180. And then if that's 33, it has to be the same size as this because it's a bisector. These angles here, that's the third property, I guess, is that the opposite angles in a parallelogram. Okay, so that's not a parallelogram, but close to it. This guy and this guy are going to be the same. So these add up to 66. These add up to 66, but you divide by 2 because they're the same size. And that's how you get y and x. Okay, so that should help you with that one there, hopefully. And then we're going to go to this one. Sorry, I just having a hard time with pulling this up. Give me a second here. Here we go. And then let me just check your email. It was let me pause this for 1 second. And once again, you got to look at the parallel. Yeah, I just wanted to check something. Okay, so this is a parallelogram, which means if that's 2.3 here, then that's 2.3 there. And the question is, how long is CE, right? So we have this triangle right here now. This guy, this guy, this guy, and you want to know what this one is here. Well, this is a right angle, and that's 1.8, and that's 2.3, so you're going to use Pythagorean theorem. So remember in Pythagorean theorem, it's a squared plus b squared equals c squared. That's what everyone remembers. Because also, that's when you're looking for the hypotenuse. Okay? And get that. When you're looking for that, you add them. When you're looking for a side that is not the hypotenuse, you write that side first. So in this case, we're looking for this one here. We can call that, just pretend that we call this A. You would call that A, and then you'd rearrange with a squared equals c squared minus c squared. So when you're looking for the hypotenuse, you add. When you're looking for any other side, you subtract from the hypotenuse. So in this case, because that's the hypotenuse, it's 2.3 squared. Subtract 1.8 squared is equal to whatever you want to call this, which we'll call x. Okay, x squared. And then solve for that. Just throw that in your calculator, subtract the 2, get your number, then hit square root, and that should get your answer. Hopefully that helps. Yeah, it's probably the parallelogram things. Remember that because it's a parallelogram, these are equal. Because it's a parallelogram, like we said over here, the bisectors meet here at 90 degrees, and that the opposite angles are equal, and that they are each the same size of each other, and then everything falls. Okay, hope that helped.